Hi everyone, welcome back to my lesson videos. For this video, we will discuss about the laws of sines and cosines. The objectives for this lesson are: recall the formula in getting the area of triangles, determine the height of a triangle using the sine function, illustrate the law of sines, derive the law of cosines from the Pythagorean theorem, and use the laws of sines and cosines in solving non-right triangles. The references for this lesson video are eMath 9 by our textbook store, Soaring 21st Century Mathematics by Phoenix Publishing House, and Pre-Calculus from Ateneo de Manila University Press. Some images came from google.com, and this PowerPoint template came from allppt.com, and also we will be using GeoGebra for this lesson video. Okay, first, let us get the area of a triangle. Okay, suppose we have triangle ABC, whose sides are A, which is opposite angle alpha, B, which is opposite angle beta, and C, which is opposite angle gamma. So how are we going to find the area of this triangle? The area of a triangle is equal to base times height over 2, or 1/2 times the product of base and height. So we have the same triangle, but we will be rotating the bases. If base is equal to AB, or in this case our side C, the area of the triangle will be equal to 1/2 times the product of C and H. And what is H? H is the height, and the height of any triangle is the line perpendicular to its base. Here's our height. So how are we going to solve for the area of triangle ABC given that our base is C? Given that our base is C. Okay, we do not know yet the value of H or the measure of H, but in this example, this triangle is cut into two parts. The smaller one is a right triangle whose hypotenuse is B, and one of the acute angles is alpha. So from these given sides and angles, how are we going to find the value of H? Okay, so in this example, our reference angle is alpha, and opposite alpha we have H. Okay, and the hypotenuse of the triangle is B. Okay, given the hypotenuse and the opposite side, the trigonometric function that we will use is sine, because sine is opposite over hypotenuse. So, sine alpha is equal to the opposite side, which is H, divided by the hypotenuse, which is B. And we only need H, so we multiply both sides by B. Therefore, H is equal to B times sine alpha. Therefore, the area for this triangle is 1/2 times C, or 1/2 C times B sine alpha. Okay, so the area of this triangle is equal to 1/2. C times B can be written as BC, then sine alpha. Next, what if the base of this triangle is at AC, or on this example at So we are going to have our area written as 1/2 B times H. Okay, so our height this time is at B. And we have the smaller triangle whose reference angle is at gamma. The hypotenuse is A. And still the height is the opposite side. Okay, so since the hypotenuse and the opposite side are the ones given, we will again use the sine function. So, sine gamma is equal to the opposite side, which is H, and the hypotenuse, which is A. Multiply both sides by A to get the value of H. Therefore, H here is equal to A times sine gamma. Okay, so the area of the triangle will be equal to 1/2 times B times height, which is A sine gamma. Or the area of this triangle will be equal to 1/2 AB sine gamma. Okay, next, what if the base is at BC or our side A? So our hypotenuse this time is opposite angle beta. Okay, so this will be our reference angle, the beta, and the hypotenuse is C, and our opposite side is the height or the altitude. And to get the value of H, we will still again use sine. So sine beta is equal to H divided by the hypotenuse C. Multiply both sides by C, so we have C times sine beta, which is equal to H. So the area of the triangle will be equal to 1/2 times A times C sine beta. So area of this triangle is 1/2 AC sine beta. Okay, since we are pertaining to one triangle only, we can say that the areas that we took from the three solutions are equal. The first one being 1/2 times BC sine alpha equal also to the area of the second triangle that we get where the base is at B. So it is 1/2 AB sine gamma, and which is also equal to the last triangle, which is 1/2 AC sine beta. Or we can also rewrite this as 1/2 BC sine alpha, so that our angles are arranged in alphabetical order. And 1/2 AC sine beta and 1/2 AB sine gamma. The area are the same, but the area is represented using different reference angles and different bases. Okay. From that, we can get the law of sines. So from our first solution, we have 1/2 BC times sine alpha is equal to 1/2 AC times sine beta and equal also to 1/2 AB sine gamma. Since all of these have a common factor of 1/2 and all have A, B, and C, we can divide everything by 1/2 ABC. Now, when we divide everything by 1/2 ABC, we can divide out 1/2 and BC, leaving us with A. Then here we can also divide out 1/2. When we divide out AC, this will leave us with B. And here, when we divide out AB, this will leave us with C. Giving us sine alpha over A is equal to sine beta over B, which is also equal to sine gamma over C, which is also known as our law of sines. And we can also write this as A over sine alpha equals B over sine beta, which is also equal to C over sine gamma. So from the given, how are we going to find the value of A? So let's take sine alpha over A is equal to sine beta over B. Also, we can equate it to sine alpha over A equal to sine gamma over C. Let's work on this one first. Since we are looking for A, so we can cross multiply, so giving us B times sine alpha over sine beta equals A. Similarly, here we are going to have C times sine alpha over sine gamma is equal to A. Okay, so A can either be B sine alpha over sine beta or C sine alpha over sine gamma. Okay, using the same method, we can also find B by equating B to the two other ratios. So sine alpha divided by A or over A is equal to sine beta over B. And we also have sine beta over B, which is equal to sine gamma over C. Now let's solve for B. We only need B, so we will isolate B here. So we have B equal to A sine beta over sine alpha. And here we only need B, so we will isolate B. We have B C sine beta, so this is that one, divided by, so bring it down, sine gamma. And lastly, when we need to find C, we equate it first with alpha and A. So we have sine alpha over A is equal to sine gamma over C, and also sine beta over B is equal to sine gamma over C. So we only need C, so we need to isolate C. So here we have cross. C is equal to the product of A sine gamma divided by sine alpha. And here, we only need C. So cross C is equal to B sine gamma over sine beta. Okay, alpha, beta, and gamma are just the terms or just the representation that we use for our angles. And A, B, and C are the sides opposite these angles. Let us remember that the angle representation is opposite to the side which the Greek letter represents. For example, alpha, let's always make it opposite A. Beta, let's make it opposite B. And gamma, let's make it opposite C. Okay, but with the law of sines, there are some ambiguous cases which we need to check to see if we are going to have a solution for our triangle. And by the way, we are using the law of sines and the law of cosines if dealing with non-right triangles, or we are solving non-right triangles. Okay, the first ambiguous case is if the value of A or side A is less than the product of B and sine alpha. That means that there is no triangle form. If the value of side A is equal to B sine alpha, that means we have one right triangle. And here's the tricky part. If A is greater than the product of B and sine alpha, we need to check if B is greater than A and also greater than sine alpha. If alpha is acute, then there are two solutions. If alpha is obtuse, there is no solution. Solve the triangle. So we have triangle ABC, whose side opposite gamma, so we will name this as C, measures 5.56. Then, since 12.47 is the side opposite alpha, let's name this as A. And this is the side opposite beta, so we will name this as B. Okay, so we need to look for side B, angle beta, and angle gamma. Okay, so let's get gamma first. Why? Because we have side C and angle alpha and side A. Law of sines says that sine alpha over A is equal to sine beta over B, which is equal to sine gamma over C. Now, let us substitute the given that we have. So, alpha is 49.59 degrees. So, sine 49.59 degrees over A. A is 12.47. Okay, sine beta. Beta is unknown, so we will leave it as sine beta. And we do not know yet B. Okay, sine gamma. Gamma is unknown, so we will leave it as sine gamma. And C is equal to 5.56. Okay, now we have values here with gamma and C, so we will solve this first. Okay, so sine 49.59 degrees divided by 12.47 is equal to sine gamma over 5.56. Since we are looking for gamma, we can isolate gamma by cross multiplication. So we have here 5.56 times sine 49.59 degrees all over 12.47 is equal to sine gamma. But we are only looking for gamma, so we have to multiply both sides by the inverse of sine, which is arc sine. So sine raised to negative 1. So we have we can use our calculator to find gamma. So gamma is equal to arc sine. So arc sine is shift sine. Product of 5.56 times sine 49.59 degrees. Again, always make sure that your calculator is set to degree mode. then divide by 12.47. So the measure of gamma is 19.84621397. So let's round it off in two decimal places. 19.84 will become 19.85 because the number after 4 is 6. So we round up 19.85. So gamma is 19.86 degrees. Okay, so how are we going to find beta? The sum of the interior angles of any triangle is 180 degrees. So to find beta, we just need to subtract the sum of alpha and gamma from 180. So beta here will be equal to 180 minus the sum of alpha and gamma. Okay, so let's just subtract it from 180. So 180 minus the sum of alpha, our alpha is 49.59 and our gamma is 19.86, giving us 110.55. Now that we know the value of beta, we can now get the length of side B by substituting to our ratios. So let's just work with sine 49.59 degrees divided by 12.47 equal to sine beta, which is 110.55 degrees divided by B. Okay, so to find B, we have A times sine beta over sine alpha. Again, with our scientific calculator, we can solve for the value or the length of B by dividing the product of 12.47 and sine 110.55. Since we are rounding off, there will be a little difference later when we check with GeoGebra if our answer is correct. Over sine 49.59, but there will be minimal difference. Okay, so the length of B or side B is 15.30. Now let us see GeoGebra to check if our answer is correct. So this is the same triangle that we have in our example number 1. So let us see if our values are correct. So beta here, we get 110.56, and gamma, the value that we got was 19.5, and the length of this side is 15.33. So let us go back to our solution. Example number 2, solve the triangle. Okay, so this is alpha because it's corner A or point A. So this will be our alpha. So opposite our side C is our gamma. And opposite our side B is our beta. And opposite alpha, this is A. Okay, so what are the sides that we are looking for? We are looking for side B and side C, and also we are looking for alpha. So alpha here should be equal to 180 minus the sum of gamma and beta. The sum of alpha, or minus the sum of gamma, which is 60.47, and beta, which is 19.43. So, the measure of alpha is 100.1. Now we can use the ratios for our to get the length of B and C. So, sine alpha over A is equal to sine beta over B and equal to sine gamma over C. Okay, so sine alpha is sine 100.1 degrees, sine 100.1 degrees all over A, which is 18.4. Then beta is 19.43, so this is sine 19.43 degrees divided by B, and also equal to sine gamma, which is 60.47 divided by C. Now let us use the formula that we had from the previous slides, saying that B is equal to A times sine beta divided by sine alpha, and C is equal to A sine gamma divided by sine alpha. Let's first get the length of B using the formula and our given. So B is equal to A, which is 18.4. So 18.4 times sine beta. So beta is 19.43. Sine 19.43 divided by sine alpha. Sine alpha, which is 100.1. So the length of B is 6.22 units. Now let's get the length of C. So C is A, which is 18.4 times sine gamma, which is 60.47 divided by sine alpha, which is 100.1. Okay, so the length of C is 16.26. Can write it here. Now let us check in GeoGebra if our answers are correct. So we are looking for, let's see if our, okay, so here for our second triangle, the values did not change, or I mean the triangle did not move. When we look back at our solution, we will be able to see that they are the same. Right? So, same. Okay, so we're done with law of sine, and this video is quite long. We are going to make this lesson video into two parts. So, first part is the law of sines. Then we're going to continue with love cosines on the next part. So please wait or stay tuned for part 2. Thank you, keep safe, and stay healthy.